Okay, just one example today. So we have a sign of mass 10 kilograms, which is to be suspended by two strings arranged as shown. We're assuming the strings are light and inextensible. And we're modelling the sign as a particle, so you don't have to worry about its centre of mass or anything like that. So that's the sign. Obviously it wouldn't look like that in real life. In terms of tensions in a string, just be a little bit careful. If the sign was being hung so that the two lengths of string are exactly the same, so if the two lengths are exactly the same, then these two tensions will be the same. And then we've got some weight acting down. If the lengths of string are different, then the tensions will be different. And the angles will be different as well, if you think about it. So for this one here, that makes sense, doesn't it? Yeah. So for this one here, we've got two different tensions. So T1 and T2. And this is horizontal, so I've got angles to a horizontal, so it makes sense to resolve horizontally and vertically. What I would personally do with this, because I just find it easier, is draw in a horizontal here, and then you've got a Z angle there, so that's 30 degrees, and that's 45 degrees sitting in there, and then you've just got everything neatly arranged around this centre point. So we're expecting two simultaneous equations because we've got two unknowns. So resolving horizontally to start with. T1, it's in equilibrium. I didn't say that. So T1, I think you'd expect it to be in equilibrium, but anyway, it is. So T1 cos 30. So we're looking for the adjacent each time, is equal to T2 cos 45. And so cos 30 is root 3 over 2. And cos 45 is equal to root 2 over 2. And I'm just going to multiply through by 2 and collect it all to one side because I know I'm going to be putting it into my calculator. That's my only reason for doing that. So that's my first simultaneous equation. I would just use your calculator for simultaneous equations if you can. Obviously, if you've got sort of unknown constants in it, it might get, you might not be able to. But right, resolving vertically, then the forces acting upwards need to equal the forces acting downwards. So T1 sine 30, so that's the bit of this force that's acting in an upwards direction, plus T2 sine 45. Is equal to the weight acting down, which is 10g. Sorry, I'm smudging again. So sine 30 is a half. So half T1 plus root 2 over 2 for sine 45 T2 is equal to 10g, which is 98. You could just put that straight into your calculator like that. I would be tempted to times 3 by 2. Doesn't really matter. You don't want to make a mistake. Times 3 by 2. And then into your calculator, two simultaneous equations, and T1 is equal to 72 newtons, and T2 is equal to 88 newtons. Sorry, it's not the best writing. There we go. And they're both to two significant figures. I hope you can still see what I'm writing. I think you can. So they're both to 2 sig fig because we're using G, which is 9.8 to 2 sig fig. So the answer will only be correct to significant figures at best. If you give your answers to more than 3 sig fig, I think it is, for mechanics, you will get penalised. So just be a little bit careful with that. But in a stats question, you need to still work to 3 sig fig or you'll get penalised in stats. So just, yeah, be sensible about your rounding, please.